Today on the bench, I want to look at the Ego 14-inch chainsaw. On a previous video, I showed the 16-inch that I bought. It performed very, very well. I come across this 14-inch shipped to me as is that stated it was non-functional. I didn't know if it was just missing pieces, that it had been robbed off, or truly non-functional. After receiving it, it was pretty obvious that it really is a major issue with the saw. I was really looking forward to taking one apart and having a peek inside. I really didn't want to take my new 16-inch apart, but I bought this 14-inch. It is the CS 1400. So I have taken all the screws out of the housing. I'm actually going to put this screw back in at the handle so it won't come apart when I put the battery in. But one thing we noticed right off is the battery indicator. When I plug it in, I noticed it should come on and show green. At least on my saw it does. So when you put this in and it doesn't show you the actual battery indicator, the light don't come on. So right off the bat, I thought it might really be in the electronics. So the saw does not work at all. So that's where I was at. I was taking the cover off. I have taken those screws out already also. Now I have taken the screws out of this shroud. That's just on there with a tie wrap. So we get a good look at how the switch works. It has a safety lock we have to push in to the center of the handle, and once we push that in, we can make the switch. We'll set this aside. We won't need it for troubleshooting. So I have a few switches here that I can actually rule out, but once again, since it didn't pick up the battery pack in place, one thing that's going to is a speed control. So get a good look at the brushless motor. The switch for the brake, as well as a very minimalistic mechanical stop to that. But mainly, I guess it goes across the switch for the brake, like a resistive brake, I'm assuming, and probably cuts the motor power as well. We'll look into that some more. But there is our, apparently, like the Hall effect feedback. Going to the speed controller, and our 3 phases to the brushless motor. We got the speed controller with a little resistor bank, and also have a electrolytic capacitor. .680 microfarads, 63 volt. It's not bulged or physically leaky. looks like some 1K ohm resistors. Maybe we'll start looking at this from overhead. Definitely no problem with the power switch. Okay, so what we have here, it looks like the blue and the yellow coming out of the speed control is going to the switch. So we got our common two in the middle, it should be. And normally it's switching to here. So the yellow to yellow, the blue to blue. So normally it's just coming out of here. It looks like we got a blue, yellow, and a brown. The brown's going straight to one phase. Then we got blue and yellow. So typically when running and the brake's not hit with your arm, or your safety brake isn't hit, then your yellow and blue go to the motor as normal. When it's hit and it switches, then it's going to kick back and switch what was going to your motor, or it's still going to your motor. The center pole for your motor is going to switch, and it's actually going to put them together. And it's going to stop the motor like a brake, apparently. Which we also look here, we have some resistors coming off of the speed control. I just want to check this switch really quick, although I don't suspect it would stop what's going on with it. So with the brake activated, it should be going to the red. So that's good. Blue is also good. And then normal should be yellow to yellow and blue to blue. Yep, blue to blue, so that's good. So no problem with the switch, either one of the switches. So our initial thoughts were probably true. It's going to be something in the speed control. I don't know how well you can see the speed controller. It does have a silicone clear potting material. One thing that's very evident, there's a 40 amp fuse right here at the very top. I can actually feel it with my finger through the potting, so it should be easy enough to get through into and probe. So it looks like this fuse may be blown. See if we can dig a little deeper in this. What I started doing is just getting my little tool and going around the edge and trying to see if I can get some of this potting material out. Just want to be careful around any components. I don't see nothing but a connector at the bottom. That's actually the heat sink thermal compound. Even though the first thing we come to looking to be an issue, that's not overly optimistic. I've been working on stuff for a lot of years, and usually when a big fuse is blown, you usually find a reason for it. And don't get me wrong, sometimes you get lucky. Usually the exception rather than the rule. So if you can see that on camera, I just got a 0 ohm reading across the battery connection with the power switch pushed. So therefore, after jumping out the fuse, before applying power, I wanted to check and see if I had a dead short going into the speed control. And as you can see, obviously it is. It is a dead short, so definitely don't want to hook battery up to that. It'll just damage something else. I did notice on tracing these white wires coming out of the speed control seemingly going to negative. If they are soldered together there, it looks like they are. We're going across negative across the top of the resistors. These are 1K resistors. Let me verify that. It looks like the color code. Oh, there we go, 1K. Wasn't getting a good connection. As I was saying earlier, it looks like the negative coming from the battery terminal is going across these resistors and going across each of the outputs of the phases for this brushless motor. It looks like I am going to have to try to get this out. It looks like they give me no choice but to try to bust the housing and get in there, so here we go. I tried to be gentle. At least I can see some Mosfets in there now. No doubt we had to get to the power side. So far, that's what we have. I definitely want to get under this heat sink. Under the heat sink has to be where your power devices are, to put out the kind of wattage it takes to run this chainsaw. There we go. Our heat transfer, our little silicone pad still intact. And I did not expect that, but it is a lot of surface mount, I'm assuming Mosfets, on that board. One thing to note, as I was jumping that fuse earlier, just testing, I mentioned you'd never want to try to put it across without checking to make sure it wasn't shorted. Now if I did want to hook the battery up to something of this nature, what I would always do would be jump the fuse in question, especially when it's a large one like this, but it'll work on anything. You can go across the load like a light bulb that's rated for that voltage. And this is a standard 120 volt 60 watt light bulb or 40 watt light bulb. So it's going to be around 10 ohms resistance across the filament. When you do this, if you have a short, your light just comes on And that's just a good trick. But anytime you trying to jump around a fuse or something that you think might have a short circuit, instead of a jumper or another fuse that could just blow or pop, and you definitely never want to just put a straight jumper across it unless you're just troubleshooting like I was, ohming, not applying power. But in this case, the 60 volts from my battery or 56 volts from my battery is actually coming across a dead short here. So the difference in potential of the 56 volts ends up across where the fuse would be, and it would have blew the fuse, but instead it just lights our light bulb. So just always good to keep that in mind when troubleshooting. I have decided I'm going to go ahead and cut the actual motor leads flush as I can off the board, and so doing that, it'll kind of separate it out. I should be able to get this connector loose from the motor connection board. There we go, that is a connector. You can see that coming loose there. There we go. It's real similar to the connectors on their battery BMS board. On a previous video we repaired one of the Ego 2.5 amp hour batteries. It's similar, it ain't the same, but it's similar to some of those connectors. And now we have this off. I'll be back with a cleaned off bench and this where we can look at it a little better. So now while troubleshooting, I have clipped off the motor leads going to the 3-phase brushless motor. If you can see this screen here on this 179 meter, I just have my K ohm resistance, which the 1K is that resistor going back to the negative terminal on the battery. So that was showing 0 ohms, and of course checking across the motor, even after clipping them off, the motor does show very low resistance. It's showing 0 ohms, which most windings on a motor that large will show really low resistance. So now I want to check this. It's not showing a short like I thought it was, but that still doesn't mean this isn't bad. If I jump out the fuse just for testing purposes and use this meter across the battery terminals plus and minus and activate the switch, well, there goes our dead short again. So it is still something on these Mosfets that is shorted. Yeah, definitely tell from our negative to our positive. Definitely a dead short. So with the first chip removed, the ground actually went away. I no longer have a dead short from ground to that first phase output. And when I check across the actual MOSFET itself that I took off. It's definitely shorted across the source and the drain. So that one was definitely bad. As I go on to the second MOSFET, this turn switching the same direction, because we noticed here we had 2 turn one direction and of course 2 turn the other. So that's switching our positive and negative. So now that's clear, but I am still showing a short coming off the positive. Yeah, that shouldn't be shorted either. So one of these two on this circuit coming off the positive is also shorted. So I'm going to have to take at least one of these off, if not both, to get that short to completely clear. It's a lot of vias and a lot of pad under these little chips for the high current capacity, so it does take a little while to unsolder these little small chips. So after cleaning the board up and checking across the pads of that second transistor removed, or MOSFET removed, I'm still shorted across those pads, which means this one here is also shorted. I believe those pads are the same. I think they're in parallel. Yep, so I think these two were in parallel, and of course these two in parallel. At the moment, with this one removed, this side's clear. And although this one was shorted, they were calling this one transistor 38, it looks like. This transistor 38 is removed. This Q32 is going to also be shorted, so I have to also take it off. So everything looks pretty good after desoldering 3 out of the 4 MOSFETs. Everything is clear now. So all 3 of those MOSFETs out of the 4 were shorted. Have one uh-oh, and that is the gate, the little pad for the gate right here. This pad for the gate has went away, so I'm going to have to do a little jumper wire from where the gate is to this 100 ohm resistor, this R88. You can see that's where the pad was, it went over. So not a big issue, but I hate that that pad lifted. The other one did fine, the pad stayed on it. So that's one of the benefits of hot air. Hot air actually hits the whole area, so even on a surface area this big, I would imagine even this little resistor would be gone. So I try to pinpoint it with the pins, with the soldering iron, taking the old ones off if I can. But it didn't seem to do too well on the little small pad. I didn't have enough heat on it directly. I was more concerned with putting the heat to the big pad to release it, and didn't go back and make sure I put heat back again on this little isolated pad. So one little fix there. Hopefully that won't be a big issue to take care of. So now we have all four removed because I just want to put all four brand new. And my camera done froze up. Doggone it. When I install the Mosfets, I just want them all four to be brand new. So that's all four removed with new solder on the pads. And also we have the 40 amp fuse has been removed also. So when I get my new Mosfets in, I'll be able to put them in place and run that small gate jumper right there if I can do it to that 100 ohm resistor. So I did get in the new power Mosfets. That is the pin out of the Mosfet package. Some of the ratings, which is a very impressive, up to 337 amps on these little things, with a very limited rating there on the note 2 on the pulse drain current 337. It does say with pulse of equal to or less than 100 microseconds at a duty cycle of equal to or less than 1%, but nonetheless it is rated for that. We also have a continuous drain current of 16 amps and up to 110 amps on the actual drain current. Of course, being a 100 volt rated package too, so very neat little package. Well, my microscope camera actually wasn't recording the whole time with these two chips. Maybe to keep recording now. We'll see. It actually froze up on me. Move on to the third one. These actually have to turn the other way, like so. I already have some solder in place. Put some more flux. Just trying to add this jumper wire to the gate to the resistor. Well, it appears my microscope is locked up again. It looks like I need to get me a hot air station as well as a new camera, which the camera still does a good job for me seeing. It's just for some reason on the SD card on this cheaper camera, it's been doing it since it was new, but it would lock up sometimes. It's gotten really bad lately. It's only recorded 17 seconds and it's locked up, and it won't power off or anything. I have to hit the reset button on the back to get it back, so. I wish I'd had it this way to start with the recording. I'm gonna make sure that you can see the screen somewhat instead of trying to record with it. Now all four of those pins are together. So that's actually okay, even though it's not pretty. That is okay. These, on the other hand, you got your 3 source, and then you got your gate, and the other 4 are all drains. So the main one is to make sure our gate with this real fine pitch device, we just got to make sure we don't get anything shorted over to that gate. That would not be good. So it looks like with a smaller tip now, I do have a good connection on the pins. On the bottom of that, that's actually the drain on this transistor. So I'm just going to go through now with the meter and just make sure nothing's shorter than it ain't supposed to be, and everything's making a connection to the pad, like the 100 ohm resistor. The 100 ohm resistor here, just going to make sure that it's going to the gate all the way through, and I got 100 ohms between there and here, or that via there, just to make sure everything's good and it's still going through the resistor, and that the resistors didn't get too hot. Make sure that they're still in good shape. They were after I put the chips down with the high heat on the larger pads of the actual drain. But after I got through with the gate and the source and tying in here, just want to make sure that everything's still good with that. Excuse the messy setup here. I got jumpers set up to the phases of the motor. You can see my temporary 30 amp automotive fuse here that I just have soldered in to the board. That's all the replaced Mosfet chips. I hadn't even cleaned the board up with alcohol good yet to get all the flux off. I have owned everything, and everything that should be clear is clear. and everything that should be going to the gates, going through the 100 ohm resistor through the gates, is going through that 100 ohm resistor is good. So now I just want to do a test with the jumpers. Not the best case scenario, but the connections are not the best, just enough to run it at no load to see if it runs. So I have a amp clamp. Let's see, set it for DC. We'll null it out, zero it. Got my trigger here ready to go. And no load, right at 3 amps. It started up good. I do want to check, especially the green jumper just signifies to me the one that I know is on the problem phase output. So I definitely want to check that one and make sure we have current draw on that leg. Even though it's spun over so good, I'm pretty sure it's working all right. Want to make sure all the Mosfets are connected good and see what it looks like on current. Well, that didn't look too promising. Check one of the others. Oh, I know what it is. I still got it on DC. Even though this is a DC input, it's actually a 3-phase AC sine wave output. So go back to AC. I'm going to go back to my green jumper. That's my problem channel or my problem phase. Want to make sure I got current on it and it looks good. Oh yeah. So there we go. Make sure they're fairly balanced. So you do need a true RMS AC amp clamp for this. Checking the output. I am very happy with that. I'm actually going to solder the connections back, actual motor controller. I want to do one final test before I actually put it back in the case. I'll have to repair the case, do it back together, and actually put it in there and put some silicone in it. But before I do that, I actually have to get the right fuse too. I'm still waiting on the 40 amp little fuse, surface mount fuse to come in. So. So I was incorrect originally when I said just plug in the battery in. I thought the indicator would come on. My 16-inch does do that, but it might be a newer model than this 14-inch I bought that needed repair. So it doesn't do it when you plug it in, but it does do it when you hit the switch. So just a correction on that. The battery indicator doesn't automatically come on until you actually hit the trigger to start the saw. So one quick thing before I put it back together, I got the oscilloscope channel 1 hooked to one of the phase outputs, and the ground, since it's isolated through the battery, I can go to the other phase output. I don't actually have a neutral, so instead of going back to the ground of the battery, I'm going across the 2 phases. So if we look at here at what we captured, I was just using the single mode. We see a kind of strange pulse here looking at it at 100 microseconds. If we take this a little bit slower, we start to see something form here. That's all the data I got. But we see there that that's our positive and our negative pulses off those pair of Mosfets to make our actual sine wave. So the first one was like the C phase, and this one's what I call the A phase. I don't know if they're actually numbered or marked, but that actually is the channel that we actually repaired. So going by the repair, we see that we do have our sine wave. So that means that both sets of our Mosfets are working correctly. What we see here is I now have the leads, one on each phase, but I'm just going to the negative potential of the battery. So I'm not reading negative to positive. I can actually only see the positive part of the sine wave, but we do see here of the phase shift between the two phases. We do see our phase shift. If I did have a 4-channel scope, we could see our 120 electrical degrees apart on all 3 of them. Of course, here I only have 2. At this point, I've let the video go long enough. So this repair has been successful. It's fully tested. I'm not going to wait on the fuse to get here to finish the video. All I have left to do is to clean the board up, put the right fuse in it, put the heat sink back on it, and put it all back together and put some silicone on it or a type of potting material to put back over it once I get it back in the original housing. Clean it up and fix the housing and get it put back in the housing. So if you enjoy watching this repair of this 14-inch Ego chainsaw, please give it a thumbs up. If you learned something from it, please subscribe, and thanks for watching. Just got this in today. Can't wait to try it out. Next up, new microscope camera.